So this video is going to have a look at factorizing the difference of two squares, which is probably a new term for you. So you'll be learning what is the difference of two squares and then learning how to factorize it. So by the end of the video, the success criteria will be you being able to factorize an expression involving the difference of two squares. So when we are looking at the difference of two squares, the standard format is a squared minus b squared. So for example, it might be 25 minus 9, which is equal to 5 squared minus 3 squared. So when you see an expression and it's a subtraction and it has numbers that result from being squared, we can use the difference of two squares method to factorize it. So the standard form is a squared minus b squared. So the factorized form, when we're using the difference of two squares, is going to be a plus b and then a minus b in our two sets of brackets. At this stage, what is important for you to remember and to understand is that we can only use this method of factorization if it is a subtraction. So if it was an addition in our original expression, we cannot use this method to complete the factorization. It has to be a subtraction. And when we write our answer, it's going to be a plus b, a minus b. So when we are completing our factorization using this method, the 4 steps to follow will be to check and remove any common factors. Then we want to identify the square root of the first term, which is going to be our a term. Then we want to identify the square root of the second term, which is going to be our b term. And then we're going to write the answer in factorized form, which is going to be a plus b, a minus b, using the two values we've identified in step 2 and step 3. So let's have a look at some examples where we can apply this method of factorization. The first one we're going to look at is x squared minus 9. So we've got our subtraction, so we know we can have a go at using this method to complete the factorization. So first step, looking for any common factors, we don't have. So then the second step is we need to identify the square root of the first term, and the first term in the expression is x squared. So the square root of x squared is equal to x. Then I want to identify the square root of the second term, which is 9. So the square root of 9 is equal to 3. So now that I've identified my two square roots of the terms from the original expression, I can write in factorized form. And that factorized form is going to be x plus 3 and x minus 3. So I'm using those two values identified in step 2 and step 3 to write in factorized form. So the factorized answer for x squared minus 9 is equal to x plus 3, x minus 3. So having a look at our second example, this time we want to factorize 16x squared minus 25. So looking for any common factors to remove. I don't have any common factors between 16 and 25. So I can move ahead and identify the square root of my first term. So the square root of 16x squared. The square root of 16 is 4, square root of x squared is x. So the square root of 16x squared is equal to 4x. Then I want to identify the square root of the second term, so 25. So the square root of 25 is equal to 5. So now that I've identified the square roots of both terms, I can write in factorized form, and it's going to be 4x plus 5, 4x minus 5. So the factorized form of 16x squared minus 25 is 4x plus 5, 4x minus 5. So moving on to our third example, 4x squared minus 81. I don't have any common factors to remove. So looking for my square root of 4x squared, and that is going to equal to 2x. So now looking for the square root of 81, which is equal to 9. So I've got 2x and I've got 9. So my factorized answer is going to be 2x plus 9, 2x minus 9. So looking at our fourth example, this time we want to factorize 7x squared minus 448. So this time there is a common factor that we can remove, and that common factor is 7. So we want to divide both terms by 7. So 7x squared divided by 7 is x squared. 448 divided by 7 is 64. So my expression turns into x squared minus 64 inside my brackets, and then 7 on the outside. So now for the moment I can ignore the 7 on the outside and focus on the x squared minus 64 inside my brackets. the square root of x squared, which is equal to x, then the square root of 64, which is equal to 8. So now I can write my factorized answer, and it's going to be x plus 8, x minus 8, because I'm using those two terms identified in step 2 and step 3. But I also need to remember that I've got the 7 sitting on the outside as my common factor that I've removed. So in my final answer, it sits on the outside as well. So the factorized answer for 7x squared minus 448 is equal to 7, x plus 8, x minus 8. So having a look at a fifth example, this time we want to factorize 20x squared minus 125. So having a look for a common factor, and I've got a common factor of 5. So my expression can be changed into 4x squared minus 25 because I've divided both terms by 5. And then that sits inside my bracket, and then the 5 sits outside of the bracket. So I now focus on my brackets, which is 4x squared minus 25, and then the 5 sits on the outside until the end. So looking for the square root of 4x squared, and that is going to equal to 2x. Then the square root of 25, which is equal to 5. So I've got my 2x and my 5 I can use to write my factorized form. So my factorized form is going to be 2x plus 5, 2x minus 5. Then I need to make sure that I'm including the 5 that I removed as my common factor. So the factorized answer of 20x squared minus 125 is equal to 5, 2x plus 5, 2x minus 5. So that's an example of how we can do the factorization by removing a common factor. Our last example we're going to have a look at is x squared minus 17. So there's no common factors that we can remove. So we have a look and see what our square roots of both our terms are. So we've got a square root of x squared, which is equal to x. And then for the next step, we need to work out what the square root of 17 is. Now, if you did the square root of 17 on your calculator, you'll get an answer of 4.12301562561.8. Now, that is not a nice even number, and we don't want to use decimals when we're doing these factorizations. So because the square root of 17 cannot be simplified, we can just leave it as the square root of 17. So our two values that we've identified is x and the square root of 17. So when we write in factorized form, our factorized form is going to be x plus the square root of 17, x minus the square root of 17. So if we have an expression that is a subtraction, and one of the terms isn't a number that we can square, we can still use this method of factorization. We just use that number, we just leave that number as a square root of the original. So the factorized answer for x squared minus 17 is equal to x plus the square root of 17, x minus the square root of 17. So there are a few examples of how we can complete factorization using the difference of two squared method. Please remember to use this method. It needs to be a subtraction in the original expression, not an addition.